Hussain, and my supervisor name is Professor Wilson. The outline of the study is first we will introduce the introduction, problem statement, objective of the study, research area, methodology, results, conclusion, and then innovations, recommendation, and publication. Let's start with the land use land cover. So what is this and why we are giving the importance to the land use land cover? As the land use refers to how people utilize the land, for example, agriculture and urban development. While land cover describes the physical material on the surface of the earth, for example, forest and water bodies. So all these are related with the urbanization. Yes, the urbanization is the main factor in the land use land change cover. The urbanization is the urban population divided by total population of a region. As expressed in percentage worldwide phenomena, especially during the last 50 years, presently 54.9% urban population in comparison to 33 in 1960. And even the projection has been made, so the 70% urban population by 2050. Forest ecosystem are significantly impacted by urbanization as they experience decline, loss, direct loss or fragmentation of forest cover. And also if we can see the temperature and precipitation are the critical factor influencing vegetation growth and hence introduce the concept of NDVI, a measure used to assess vegetation health using satellite imagery. The problem statement of my study is life in Pakistan, Rawalpindi district is experiencing rapid transformation in landfall due to various factors such as climatic variability, forest improvement, and human activities. These changes affected by urbanization and population growth, internal migration, and rural to urban migration, causing the problems include loss of biodiversity, degradation of water quality and quantity, and forest fragmentation. These dynamics pose a significant threat to a robust economy of Rawalpindi. To address these changes, making and monitoring of land cover changes is required. The objective of the study is to analyze long-term land cover change in which we will find out the historical from 1992 to 2022 the land cover changes and the pattern of transition. And to identify the change pattern in transition, to conduct future land cover simulation, and then after that we run the model and the future simulation to the 2052 we find out the land cover. And to assess the forest fragmentation, as we have seen that the forest degradation is the major product in the study area, that's why we find out the forest ecosystem point. So we find out the assessment of forest fragmentation. To investigate environmental effects on vegetation, and also we find out the vegetation health, which parameters are impacting the vegetation health. The research area is the Rawalpindi district of Punjab province in Pakistan. Overall, if we can see the Pakistan forest area account for less than 4% of the overall land area. Study region is primarily made of the evergreen conifers and subtropical deciduous forests. The population in the study area has reached approximately 6.1 million in 2023 with a growth rate of 2.1% observed over the same period from 2017. The research methodology is the overall I have shown in the technology round. Here we can see that the data collection, how we made it. First of all, we downloaded the data from the Landsat imagery for 1992, 2002 and 2012. Landsat Park imagery is used, and for 2022 Landsat 8 is used. And with all these, the field data is also collected for the accuracy and model assessment. And after that we find out and derive the variables which used in the model for the Markov chain model. So we use the slope aspect, urban, evidence likelihood, growth and elevation. And for climatic variables we use temperature, precipitation and NDVI. The data analysis in this step we find out the classification like we did SVM classifier. After that we find out the model accuracy and also the forest fragmentation. First of all we reclassify the area of forest and non-forest class and then run the forest fragmentation tool. And also the regression model is used for the environmental results include the thematic land cover map, change detection, transition area matrix, and land cover simulation part 2032, 2042, and 2052, and the hard and soft warm-up land cover. Also the forest fragmentation map and degradation of forest types, and also the temperature analysis like the relation of NDVI, land cover, temperature, and precipitation. Let's move toward the results and discussion. The results are divided into 4 parts. The land cover change analysis, future simulation of land cover through Markov chain model, forest fragmentation analysis, climatic variables, correlation with land cover. And land cover chain analysis, we use support vector machine classifier. Support vector machine classifier based on statistical learning theory minimize generalization error by finding a hyperplane that maximizes the margin between classes. Kernel methods transform non-linearity separable data into separable higher dimensional space. In the model formulas which use as shown in the figure, also the model accuracy is calculated, and the model accuracy for 1992 is 81.7 and 79.4, 81.1 and 87 for the 2002 and 2012 and 2022. Also we calculated the ROC for the model accuracy. This is the classified map for the 1992, 2002, 2012 and 2022, in which we can see that the authenticity is the main region and main hub of that area, is also it is touched with the capital of Pakistan, so it's important. That's why we need to monitor the land cover mapping for that area. And this is the Textile region, mostly the Kent and the main areas are having here. And this is another urban area. And this is the major portion of forest. As we have seen that in our study area, the Murray and Kotli Satya Tehsil are the major forest regions. That's why we focus for the forest fragmentation in this area. Land use change table shows the areas in kilometers square, just like the conifer class. We take the subtropical forest. Arable land include cropland, grassland, fallow land, barren land, bed-up area, and water. And after all that, the overall accuracy and kappa accuracy is calculated for 1992, 2002, and 2012 and 2022. This is the graphical representation of data, and it shows the percentages for 1992, 2002, 2012, and 2022. Here we can see that the forest area, subtropical forest, 21.1% in 1992, while in 2022 it reduced to 17.5%. The same is like we see the conifer forest 6.5 in 1992, while in 2022 it reduced to 3.4%. The trend shows the classes trend, the upward and downward trend, as like the forest area shows the downward trend, while the built-up area and the agricultural land show the upward trend. So it shows the human factor impact on the forest area. The gain and loss of the forest cover shows the projects, how the project is going in the area, like how much the loss and how much the gain. So it represents the overall study area scenario. Transition of area between land cover classes highlights significant increase in arable land and urban land categories. The significant decline in forested area observed in research address the environmental issues and changes, particularly regarding biodiversity loss and climate change. The net change occurred in the study area. The significant variation observed in the land cover change between 1992 and 2002 and subsequent decades. The expansion of built-up and arable land is the key sources of pressure on forested ecosystem. Influence of human activities and policies on land use changes. The data from 1992 to 2012 clearly show substantial transformation in population growth, built-up areas, arable land, and forest land, highlighting the influence of human activities on landscape. The high R value of 0.944 between population and built-up area indicates a strong correlation suggesting that urban expansion is being largely driven by the increasing population. In the table, we represent the population, the built-up area, and the arable land, which shows the impact, like the human impact on the land or changes. Also, the R value represents the correlation. The next is a future simulation of land cover through Markov chain models. In Markov chain model, here if we can see the input layer, middle layer, and output layer is divided into three parts. The input layer is the T1. T1 is the initial layer, is 1992. T2 is the 2012 year. And the model output is the soft and hard image, as we have seen the observed 2022 and predicted 2022. So after that, we validate the model by the last year. The input neuron is 6 layer, the hidden layer neuron is 7 layer, and the accuracy rate is 89.08%. The scale measure is 0.87%. Model input variables are the aspect. We taken for the Markov chain model is aspect, proximity to urbanization, proximity to road, elevation, proximity to rival, and evidence likelihood. These are variables representing the nature factor also and the human factor also, just like the proximity to road and proximity to urbanization. The model accuracy, high agreement rate. The MNP model demonstrated a high accuracy with agreement red seal value of 0.52. Over 52% of red seal were correctly classified, indicating the model effectiveness. Substantial agreement indices. The K no standard 0.85, the K location is 0.83, the K standard is 0.81. These values are above 0.80, reflect substantial agreement between predicted and observed classification. And the disagreement is very low, which shows that the image is classified accurately. The land cover map for the 2022, 2042, and 2052 shows very clear visualization of the urban area, how it is improving and how the forest is decreasing. This is the graphical representation for 2032, 2042, and 2052. Here we show the percentages of the land cover classes, as the urban area is 10% in 2032, and 13% in 2042, and 14% in 2052. Land use change table for future simulation is we have shown here. The most significant changes are observed in built-up area, indicating urban expansion as a dominant trend. Forest area represented by CF class and SKF show consistent decline, highlighting deforestation as a concerning issue. Arable land remains relatively stable, suggesting a balanced approach to agricultural expansion. The next topic is forest fragmentation analysis. In forest fragmentation analysis, we select the area, those areas which have forest species in the main forest region. Forest fragmentation is the disintegration of forest land into smaller pieces of land and fragments. Choosing this region is important because this area is rich in cheap pine forest, a significant part of local environment. By studying how the habitat is fragmented in these specific forests, we aim to understand the detailed pattern and changes in this spatial ecosystem. Landscape fragmentation tool, we use the LFTV model developed by the author, as well established framework that classifies landscape fragmentation by scrutinizing image morphology, provided by the University of Connecticut Center for Land Use Education and Research. Classifies land cover map into core, edge, patch, and perforated forest, with the core forest further categorized into small, medium, and large core based on the area. The forest fragmentation map shows the classes. Here we can say that the patch, edge, perforation, and small core, medium core, and large core for 1992 to the 4 period until 2022. Here we can see in 1992 the large core area, the main habitat of forest is larger and more, while in 2022 it is degraded and perforated or converted to other classes. It shows deforestation in that area. Forest fragmentation analysis. Here we can see that the steady increase in page size until 2012 followed by a slight decrease in 2022. Initial increase in population until 2002 followed by a significant decrease by 2022. Large core area decreased until 2012 then partially recovered by 2022. Forest fragmentation transition from 1992 to 2022. Major transitions such as permanent shift of 27.2 km square from large core to edge forest indicate disturbance in fundamental habitats and potential biodiversity loss. Large core area undergoes shift into corporated landscape 35.9 km square, highlighting vulnerability and potential decline in habitat quality and increase in edge decades. The last point is climatic variable correlation with land use land cover. Here we can see that the variable we selected for the model is NDVI for each land use land cover, and the NDVI is only selected for the summer period. As the same way, the mean temperature of summer, June, July, August month, and the mean precipitation of summer we have taken for the analysis, because the land cover that we taken for is also the June period. That's why we select the summer time. The extraction of the data is we have taken the 1200 points and 200 points in each class, and then we run the correlation analysis in linear regression to find out more about the climatic variables. The correlation analysis of NDVI temperature and precipitation across different land use and cover types shows that the NDVI in 1992 to 2022, here we can see the conifer forest and subtropical forest NDVI value is higher, while the water NDVI value is lower. So let's evaluate the land cover, that how our land cover is classified. It shows the accuracy of land cover classification. In the same way, temperature in 1992, the temperature in the forest area is lesser and lower, while in other classes temperature is higher. Also, the precipitation in 1992, the precipitation value is higher, while in 2022 it is lower. A correlation between NDVI temperature precipitation across different land cover types, temperature and NDVI relationship. In agriculture areas, higher temperatures correlate negatively, minus 0.55 with NDVI, indicating potential stress on vegetation. Conifer forest, the correlation between temperature and NDVI is less negative, minus 0.35 compared to agriculture region, which might suggest that conifer vegetation is more resilient to temperature variation. Urban area display less impact of temperature on NDVI, minus 0.03, indicating that urban vegetation might be adapted to extreme temperatures. The second part is precipitation impact on NDVI, the unusual negative correlation between NDVI and precipitation, minus 0.28 to reflect the limited soil and water retention capabilities typical of urban environment. A slight negative correlation between precipitation and NDVI, minus 0.14. This pattern suggests that vegetation in barren area might respond favorably to warmer conditions. And temperature and precipitation pattern, the strong negative correlation between temperature and precipitation is minus 0.86 in arable land class, could indicate seasonal variation where higher temperature correlate with drier period. The correlation between temperature and precipitation is minimal, as 0.07 negative, and conifer forest suggests more stable climatic condition. The confidence level of the model variables. Each interval analysis is based on linear regression model that quantifies the relation between NDVI and the predictors. Significant interaction between here and the other variables suggest changing impacts of temperature, precipitation, and land use on NDVI over the decades. The predicted correlation between NDVI temperature, precipitation across different land use and cover types. The analysis represents the relationship of NDVI and environmental variables such as precipitation and temperature across various classes. As we have seen that the conifer forests have the higher NDVI value, but it is increasing with the precipitation. With the precipitation increasing, the NDVI is also influenced with the increased trend. And the same way, the temperature, as we have seen, it is impacted but not too much high or not more significant as like the precipitation. The conclusion over the 3 decades when there has been a significant decrease in forested areas in conifer forest and subtropical forest. This decrease is linked to the expansion of agricultural activities and rapid growth of urban areas. Future predictions based on the human urban system indicate ongoing urban growth at the expense of forested region. The study highlights the importance of implementing sustainable land use policies and conservation initiatives. Higher temperature negatively impact vegetation health and agriculture and built-up area, highlighting the need for measures to mitigate heat stress and on vegetation. Understanding these relationships is essential for guiding land management and conservation strategies to preserve ecosystem integrity and biodiversity in Rawalpindi district. The innovation of the study is utilize a combined approach of multi-layer network and CMRO models to accurately predict the future land use land cover changes and systematically analyze the land use land cover changes in Rawalpindi district from 1992 to 2022, providing detailed pattern and driving factors of change over the long-term scale. Applied the Earth-based landscape fragmentation tool for the first time in Rawalpindi district to study forest fragmentation and its impact on biodiversity and ecosystem health, and also revealed the dynamic impacts of climatic factors such as temperature and precipitation and human activities such as urban expansion and agriculture development on vegetation health through time series analysis, and also conduct a comprehensive assessment of land cover changes by integrating both natural and socio-economic factors, proposing targeted land management and conservation strategies. The recommendation of the study is to implement sustainable land management practices, strengthen the conservation efforts by enhancing the protection of critical forest areas, integrate socio-economic factors in land use model to improve accuracy, promote urban planning and development control, support reforestation and afforestation initiatives, develop climate resilient land management strategies, strengthen legal frameworks and enforcement, promote interdisciplinary research. And this is the publication from this study as we have it.
认为很好，就是建议有价值，就是一个建议啊，就是你把那个驱动因素，
这个是建议 PPT， 好，记完之后到时候转给这个
驱动因素就是在第4章结构里面最好单独这一部分写出来，就把那个人为因素、自然因素单独体现出来，因为根据你的题目的话，你的这个还是有一定的这个因此的这个位置好哪里啊？
Some suggestion that you start not have to investigate the landscape change and you calculate the landscape change metrics. But I suggest that you should focus on the driving factor. So evaluate which factor has most important the impact on the landscape change. And based on the driving factors, I think you should to find some main reason for the change and then give the recommendation to the local government for the sustainable forest management. It's the way folks. But you spend a lot of time to investigate the relation between NGV and the land cover tag. I don't think it makes sense. Okay? So the second thing is that the assembly design. You write down in page 35. You name it road stamping. I don't know what is road stamping. Something include development stamping, systematic stamping, and I don't know road stamping. Road stamping. So please use statistical based stamping techniques to track to the ground control. Okay? Yeah. And that's all.
Could you please go back to your application? Or if there is a missing in your thesis, you need to add your application on this, alright? And Your publication.
Publication?
Yeah, yeah.
Oh, okay.
Last page.
Thanks. Okay.
Okay. So before I went to the go to the recommendation, this thesis not necessarily guarantee your graduation before you reach the PhD requirement, right? Because you only have one publication for now. Is this reach our requirement?
The last, the number 4 is the, this one.
No, the first paper. Is that
No, the first paper is not enough.
it's not enough.
Yeah.
So your current publication may
And
not.
just like this one. Sorry. This one is under final decision
Okay.
pending, so maybe in a month, I
Alright.
will get the decision.
So just to let you know, right?
Yeah.
In the second one.
Yeah.
And two general comments. The first, the object of your study, and actually this is your hypothesis, is your scientific goal. It's different between study content, right? What you write now is a research content, not hypothesis. Okay? You need to rewrite this part. And the second one, your innovation point. From what I see, this part is more like a particular method and result. The innovation point is what makes you different between this and that study, right? Your unique point. Right? Yeah.
I said that you do a lot of the work, the plan is very good. And I want to know, you will have the first inventory data in the paper.
Inventory data, you mean the field data collection?
Around the inventory.
Yeah. I have collected 250 points by self. Like first of all, we generated the random points and are classified here, and after that we collect the 250 points by self, and mostly 200 points from the forest department for those areas which is not reachable. So after that I use the model accuracy and
Okay. I think because the result, all results from go to sensing test,
yeah.
you will have the first inventory data. You can compare it with the ground.
Yeah.
That will be better.
Yeah.
I have a question you can answer the basis
Oh.
of the
As like he mentioned about the vectors for the land use land cost changes. So overall, if we can see Pakistan is not is like a developed country. So mostly the factors which we want to collect or which we want to use for our analysis, mostly it is not available on the ground. Like for the historical, like 1992, at that time we don't have. Now I have, but that's why we select those variables which is accessible and which we can take this variable. And another question he told me about the factors, human factor which is not good, we can say that like that. So for that reason, as I have seen that urban area and agriculture area, I have explained